Good morning everyone. My name is Magar MH, Assistant Professor from GMD College, Senior. Today I have discussed about new chapter number 3, Quality of Irrigation of Water from PYBSc lecture first. First, introduction. Water is the most important part which man has exploited than any which resource for his life. Most of water on this earth is stored in ocean ice caps difficult to recover for our diverse needs. Most of our demand for water is fulfilled by rainwater which gets deposited in surface and groundwater resources. The quality of the quality of this utilization water is very difficult limited on this earth. What is the pure water? The pure water is considered to be that which has low dissolved and suspended particles and gases as well as low biological life. Such a, such a high quantity of water may be required only for the drinking purpose. For other uses like agriculture, industry, the quality of water can be quite flexible. Water is usually classified as hard or soft according to their concentration of calcium and magnesium ions. The water is also called as carbonated, sulfate, nitrated depending upon the concentration of their ions. Next point is source of water. The source of water can be divided into four classes. First is atmospheric water, second is surface water, third is stored water, fourth is groundwater. I explain one by one. First is atmospheric water. The rainwater and water formed by snow are grounded under the atmospheric water. Second, surface water. As soon as raindrop and snow splash reach to the surface of the earth, they are quietly become contaminated with the soil microflora of their area. Such water facilitates the growth of species and protozoa. River water show their highest count during rainy season. Third is stored water. The water which is present in pond, reservoir, lake or ocean for considered period is called as stored water. The microbic population increase greatly in a such water. Fourth is groundwater. When the water meets rock that has no porosity, such water is called as groundwater. In groundwater, when raindrops fall on the dry soil, they will wet the soil particles. As the rain continues after on the land surface will wet, gravity will be pull the excess of water down to the space in the soil. That means sand, rock, slime, etc. The large the underground space is, the faster the water will be flow down. Finally, downward flow of water will be stopped. When the water meets rocks, then has no porosity, such water is called as groundwater. The saturation of water in the soil are at particular level, that zone is called as saturation zone. The upper boundary of the zone of saturation is called as the water table. Next is impurities in water. The, anything in the water that is H2O is a contaminant or purity. All the water is impure and it is the principal job of the water chemist to define this impurity. It is important to recognize that the term impurity, contamination and population are subjective ones. Next, water quality contamination in the raw water. The unique ability of water is to be dissolved to some extent. Virtually every chemical compound and support practically every form of life means supply contains many contaminants. Next is the major impurities found in raw materials. First is suspended particles including colloidals. Second, dissolved inorganic salt. Third, dissolved organic compounds. Fourth, microorganisms and pyrogens. Fifth, dissolved gases. First, suspended particles. In a suspended matter in the water including slide, pipework, debris and colloidal. Colloidal particles are not to be in the solution or suspension. It gives to rise to has turbidity in the water. The degree of colloidal contamination can be determined by a fluid index turbidometric method. Second, dissolved inorganic salt. Dissolved inorganic substance in the solution including hard salt. The bicarbonate of calcium and magnesium gives rise to temporary hardness of water called temporary hard water. The, the sulfates and chlorides causes permanent hardness is called as permanent hard water. The other inorganic impurities present in the water are carbon dioxide, sodium salt, silicates, ferrous ferric iron, phosphate and nitrate which are present in raw water. How is the amount of dissolved in inorganic measured? Firstly, total dissolved solid, that means TDS, is the residue in pythium obtained by the traditional method. Firstly, evaporating a water sample, then this water sample is dried and heating at 180 degrees Celsius. After 180 degrees Celsius, this residue includes colloids, non-volatile organic compound and salt are formed. The stable at this temperature, peak temperature 180 degrees Celsius. It is a greater portion of residue in inorganic salt. This TDS means total dissolved salt is used as an indicator for the total level of inorganic compounds present in still water. Next, dissolved organic compound. In dissolved inorganic compound, the unique substance found in a great amount in snap water impart a yellow or brown hue. Contamination of raw water by organic substances is mainly due to first, drying and drying off and decaying of organisms prevailing in water. Second, unpurified wastewater discharged by industrial into water reservoirs. All the organic substances present in water are not in colloidal state. Fourth, microorganisms. In microorganisms, biological impurities are also present in water. The biological contaminants may be microorganism, bacteria or viruses. The two most common microorganisms to contaminate a higher water source are Giardia and Streptococcus. The chemical treatment are typically less effective against these than by boiling and filtering. The boiling and chemical treatment are typically more effective against bacteria and virus than filter. Next is dissolved gases. In dissolved gases, all natural water also contain gases of which oxygen and carbon dioxide causes corrosion of metal. You know corrosion of metal, that is burns. This treatment of boiler feed water must include degasification. Dissolved gases such as O2, CO2, H2S, etc. may be present in water as impurity. For the removal of these gases, it is better to classify them into two classes. First, gases which are removed when the solution is heated because solubility of gases in water decreases when the temperature is increases. Second, gases which can only be removed by chemical treatment. For example, oxygen from water may be removed by passing water over hot iron. As a result, iron oxide to ferric state and is precipitate. 4 Ap, Ap means iron. 4 mole of iron plus 3 mole of oxygen, that means O2. It gives 2 mole of Ap2O3. The knowledge of water quality and its contents are essential for judging it suitable for various purposes like public health, irrigation, industry, and environmental safety. Thank you.